Day 13, let's go! Distress signal. You climb the hill and again try contacting elves. However, you instead receive a signal that you weren't expecting. A distress signal, as the title would indicate. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of packets, your puzzle input, to decode the message. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. For example, blah, blah, blah. Okay, great. This looks annoying. Packet data consists of lists and integers. Each list starts with a bracket, ends with a bracket, and contains 0 or more comma-separated values, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called the left and the second value is called the right. Then, if both are integers, the lower integer should come first. If the left integer is lower than the right integer and inputs are in the right order, or the inputs are in the right order, if the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next part of the input. Okay. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the list, or the input. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value, then retry the comparison. For example, if comparing list of 0, 0, and 0 and singular 2, convert the right value to a list 2, and the result is then found by comparing list of 0, 0, 0 and list 2. Using these rules, you can determine which of the pairs in the example are in the right order. So in pair 1, we can compare our list and a list, and then first item of the list is 1, second item is 1, so we continue comparing, and then compare 1 and 1 again, so we continue comparing, and then 3 and 5, 3 is less, so they are in the right order, we do not care about the rest of the list. Pair 2, compare list of 1 and list 2, 3, 4 versus... Oh my gosh. Okay, compare list 1 versus list 1. Compare 1 versus 1. We're good. Continue on. Compare 2, 3, 4 versus 4. 4 is a mixed type, so we convert it to a list and retry. 2 is smaller than 4, so we are good. And so on and so forth. And oh my gosh, that is so much crap. What are the indices of the pairs that are already in the right order? The first pair has an index 1, the second pair has index 2, and so on. And in the above example, the pairs in the right order are 1, 2, 4, and 6. The sum of these is 13. Determine which pairs of packets are already in the right order, and what is the sum of the indices of those pairs. Great. Okay. So I'm just going to walk through today's solution again. And one thing I'll say is from the beginning of the Advent Code this year, I wasn't really trying to go for fastest time or anything. I wasn't trying to go for like code golf. I wanted to practice algorithms and stuff like that. I consider this good interview practice, and a lot of these algorithms I have not touched since college. So it's kind of a good practice to go through them every once in a while. As far as for learning purposes, if you find that interesting, that's fantastic. Stick around. If you have not yet gone to college, or you're just an amateur and you want to kind of see how some of these algorithms work, again, great. But there are definitely external libraries that will do a much faster job of this than I did today. And some of them are even Kotlin released, like the Kotlin Serialization library should be able to do a lot of this kind of stuff. I did not go that route. I actually built my own parser for the day. It was painful, but good experience. So definitely good practice. Anyway, we'll walk through that. Basically, I made a comparator which takes an A string and a B string and returns a nullable boolean. If it's true, that means A is less than B basically. If it's false, that means B is less than A. And if it's null, that means they're equivalent. And basically, at that point, I just went through the list of criteria that are given to us from the Advent code. And so basically, if they're both integers, do the compare. If one of them is an integer, turn it into a list, turn the other into a list, basically. Check for empties. And then past all of that, I have basically these elements arrays, which are going to be mutable lists of strings. And then I'm going to build those out with every element in the list for our current element. So basically, it's just going to iterate through there, and if it sees a bracket starting, then we know we have to go find the matching bracket, and we take that whole substring becomes an element. If not, then we go through the list, and then every item in the list becomes an element. And basically just kind of run through it that way. And then I do that for B as well. Probably can clean some of this up. Again, clean code is always in the GitHub. And if you want to see how any of that stuff specifically works, again, GitHub. So I can kind of show you basically what those look like here. So like the first test here is 11311 versus 11511. And we'll see that those are the strings that came in. And then the elements are just going to be the elements of the array, 11311, 11511. And then it will, for each item, it's going to pop the first one off. It's going to recursively compare that first item again. And then if it returns true, it just returns up the stack. If it returns false, returns up the stack. If it returns null, that means they're tied. It's going to pop the next item and go again. So if you think of like a tree structure, it's going to start on the bottom left, and it's kind of just going to go up and down until it finds something that returns a true or false, and then return it all the way up to the head node. So like if we look at like say the next input, which is a list of 1 and a list of 2, 3, 4 versus a list of 1 and the element 4, then that's going to come in here as a list of 1 versus a list of 2, 3, 4, and so on. And so like we step into here, then we're now going to walk through the next comparator, which is again recursive. So it's going to be the element 1 versus the element 1, and that's going to return a null. And so then the next time through, we're going to compare 2, 3, 4 versus just 4. 4 will be turned into a list, and so on. Again, not going to go through the specifics of all that. It's in the GitHub if you want to go that depth. And then a couple of those cleanup things. If one's empty and the other one's not empty, of course, we check those as well. But by building it as a comparator, it allowed us to do some cool stuff on the side. So for example, part 1, I can just take the input and I can do map indexed, which is going to basically do a map, but for each iteration of the map, we have an index. And then that for each item, basically, I'm going to compare the list of, or the A list versus the B list. And if it's true, then I'm going to return that index plus 1, because that's the item that we want. Also 0, and then sum them up. And so that's our entire answer for part 1. And then for part 2, stick around. Okay, so let's see what happens. 6240, okay. There's no way this works. Holy moly, that's the right answer. You're 1 gold star closer. Continue to part 2. Hey, but on the upside, now exactly halfway through Advent of Code. Alright, now you just need to put all of the packets in the right order. Oh my gosh. Disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional divider packets. List of 2, list of 6. Using the same rules as before, organize all the packets, the ones in your list of received packets, as well as the 2 divider packets, into the correct order. For the example above, the result of putting the packets into the correct order is a bunch of stuff. Great. And then we also need to add 2 and 6. Great. Afterward, locate the divider packets. To find the decoder key for this distress signal, you need to determine the indices of the 2 divider packets and multiply them together. The first packet is index 1, the second blah, blah, blah. In this example, the dividers are 10 and 14. The code is 140. Okay, let's grab that. 140. Organize all the packets into the correct order. What is the decoder key for the distress signal? Okay. The cool thing is, because we've basically just built a giant comparator for 2 strings, we can do a sort with this comparator as our sort key. And we're good. So the only thing we need to do is we need to add 0, 0, or the list of 2 and list of 6. I can just go into input and just type them in. I guess we'll go ahead and do it the correct way. Whatever. All right, so val clean input is equal to a mutable list of string. And then for I in input, for j in I, sure, whatever. And clean input dot add j. Great. All right, so that's just going to iterate the outer list of pairs and then iterate the inner list of lines. All the bad lines have already been removed. They're out. Okay, great. And then we're just going to do a clean input dot add of, we need to add bracket, bracket 2, bracket, bracket. And then clean input dot add bracket, bracket 6 dot bracket, bracket. Okay. Okay, and then should just need to do clean input dot sort with comparator string comparator string. Does that work? That might work. Did not work. Check failed. Okay, so let's see what our, oh, I returned 0. Yeah, okay, well first off, let's see what our actual list looks like and make sure it looks correct. And then it is supposed to be empty. Okay, so I've got them backwards. I've got them backwards. Not a problem. Not a problem at all. All right, hit it again. Boom, boom, boom. Okay, everything is right. Then all we need to do, clean input dot index of 2 times clean input dot index of 6, and then they do not 0 index, so I will not 0 index either. And then let's see if that works. 23142. And then that is the right answer. Okay. Anyway, that was definitely one of the most annoying comparators I've ever written in my life. Kind of wish I had done this in more of a scripting language for today, but then it wouldn't be additive code in Kotlin. So, you know, you win some, you lose some. Anyway, we are more than halfway done. Yes, and I will see you guys tomorrow.